In this video, we are looking at similar shapes, which are shapes like these two that have exactly the same shape but are simply different in size, meaning one is a scaled up or scaled down version of the other. You might be able to tell just by looking if two shapes are similar, particularly if they look the same in structure but differ in dimensions. But to be completely certain that two shapes are similar, you would need to verify that all of the corresponding angles within each shape are exactly the same. For example, when we fill in all the angles in both shapes, we can clearly see that each shape has identical angle measurements, and this confirms with certainty that the two shapes are indeed similar, even though their sizes differ. Now, in exams or problem-solving situations, rather than asking you to simply identify whether two shapes are similar, the question will usually state that they are similar and instead ask you to calculate an unknown side length from one of the shapes using the properties of similar figures. For example, if we examine a question where we are told the two shapes are similar and asked to determine a missing side labeled x, the key strategy is to identify the scale factor between the two shapes, which tells us how many times larger the bigger shape is in comparison to the smaller one. To find the scale factor, we compare two matching or corresponding sides, like the bottom sides in this case, and calculate how many times bigger the larger side is than the smaller one. Since 6 centimeters is 2 times larger than 3 centimeters, the scale factor in this case is 2, which we can also determine by dividing 6 by 3. This tells us that every length on the larger shape is double the length of the corresponding side on the smaller shape. So, to find the value of x, if the matching side on the smaller shape is 5 centimeters, we simply multiply 5 by 2, resulting in 10 centimeters, meaning x is 10 centimeters long. Let's try another example to solidify this understanding. In this example, we are told that two triangles are mathematically similar and asked to find the missing side lengths labeled x and y. It is important to note that the term mathematically similar simply means the same thing as similar, so both terms are used interchangeably in exam questions and mean that the shapes are identical in form but different in size. Just as before, the first step is to determine the scale factor between the two triangles. We can do this by comparing a known side from each triangle, such as the 8 centimeter side and the 12 centimeter side. To find the scale factor, we divide 12 by 8, which gives us 1.5, so the scale factor is 1.5, which means the larger triangle is 1.5 times the size of the smaller one. We can say that the larger triangle is an enlargement of the smaller one by a scale factor of 1.5. Once we have the scale factor, we can use it to find the unknown side lengths. For example, to find x, we look at the corresponding side on the smaller triangle, which is 26 centimeters, and multiply it by 1.5 to get 39 centimeters. So x is 39 centimeters long. To find y, we need to reverse the process because y is on the smaller triangle, and its matching side on the larger triangle is 45 centimeters. Since we are going from a larger shape to a smaller one, we divide 45 by the scale factor 1.5 to get 30, meaning y is 30 centimeters long. If you ever get confused about whether to multiply or divide by the scale factor, just look at the direction you are going in. If you're going from a smaller shape to a bigger one, you multiply. If you're going from a bigger shape to a smaller one, you divide. This logic helps make sure you're using the correct operation. Finally, one last helpful tip before we finish is that it's usually easier and more straightforward to calculate the scale factor from the smaller shape to the larger one, like we did in this question. You can find the scale factor from the bigger shape to the smaller shape too, but that will give you a number less than 1, which is generally trickier to work with. For instance, if we wanted to find the scale factor from the larger triangle to the smaller one, we divide 8 by 12, which gives us 2/3, and that tells us the smaller triangle is 2/3 the size of the larger one. Working with fractions or numbers less than 1 can make multiplication and division more complicated, so it's usually best to stick with finding the scale factor from small to big. Anyway, that's everything for this video on similar shapes. If you want to practice solving problems like these or any other questions in subjects like science or mathematics, you can visit our resources website by clicking the link in the top right corner of this screen. Thanks for watching, and we'll see you next time.